Chapter 6, Section 1, Question 1. We're going to find the domain, and we're going to use this symbol, which is a do not equal symbol. And it's the only place we're going to use it in the entire chapter. In fact, in the entire MAT 099 course. So, we're going to use it to see when the domain of this is bad. There is a special answer, which is x such that x is a real number. You'll remember this from chapter 1. This is set builder notation. It has the variable, and then it has the property. So for each of these, what we're going to do is we're going to factor, solve it for equals to 0, and then determine what the domain is. So what we want to do is only at this point in time, look at the denominator and set it equal to 0. First, we notice that we have an x cubed. We don't normally have x cubes. We're going to factor out an x from every single term that is factoring out our GCF, because the first thing that we taught you is the first thing that you'll forget. And then we're going to factor this trinomial. Hopefully at this point you know how to factor trinomials. And so the 6 will break up into 2 and 3. We want it to subtract to give you 1. So we want the 3 to be positive and the 2 to be negative. We want all this to equal 0. From back in chapter 1, we learned about the multiplicative property of 0, which means if things multiply together and it equals 0, someone has to equal 0. So first, the x says, I can equal 0. Hey, that's one of our answers. And then the x plus 3 says, but wait, I can equal 0. And we solve that beautiful little one-step algebra equation. And we find another answer. And then the x minus 2 says, I can equal 0. And we solve that beautiful one-step algebra equation. And we now have all 3 answers of what could make this expression equal to 0. So if you look here, this says x to the third. The degree is 3, and so there are 3 answers. It means that often, when this is a degree of 3, you'll have 3 different answers, but eventually we'll have some of them that are repeats. The way we're going to write this in set builder notation is we of course have the variable x, and then we're going to have x does not equal. Notice, we have 3 numbers here. We want them written in order from least to greatest. So negative 3 comes first, then 0, then 2. Eventually, we're going to put this on a number line, and then we're going to write this in interval notation. So in interval notation, first we're going to say, here's negative 3, 0, and 2. These are not equal, but everything else is. So there will be 1 piece in our interval notation, 2 pieces, 3 pieces, and 4 pieces in our interval notation. This is the answer that we want at the 099 level. This is how we're going to get to the answer at the 121 level. You'll remember from chapter 2 that interval notation, we want to start on the left and head towards the right. We're going to start off, because of this arrow, with negative infinity, and infinities always get parentheses. It will then stop at negative 3. Because of the open circle, we'll have a parentheses. We put the U for union. Remember, we don't use the intersection symbol anymore, just in chapter 1. And then it goes from negative 3 to 0, again, open circle, so parentheses. And then from 0 to 2. And then from 2 to infinity. This is one of the reasons why we want to write this in order from least to greatest, because the negative 3 shows you where the first break is, the 0 shows you where the next break is, and the 2 shows you where the last break is. Then we want to look at this one, x squared plus 9. We want to look at x squared plus 9 and see when that is equal to 0. You might think that this factors, but it doesn't. If I were to write this out as x squared plus 0x plus 9 equals 0, we want to know what pair of 9 adds to give you 0. 1 and 9 adds to give you 10. 3 and 3 will subtract to give you 0, but it will not add to give you 0. This is not factorable at this point in time. So since this doesn't factor, we're going to use our special answer, which is that x is a real number. Now, since you're doing this on your homework, your quizzes, your tests, your midterm, your final, I don't want you to write x such that x is a real hashtag. I want you to write x such that x is a real number, because just like with your English classes, I don't want you to be abbreviating there. Chapter 6, Section 1, Question 2. We're going to factor, cancel, and write a better answer. So what we're going to do here, this, if you remember from Chapter 5, Section 4, we had factoring by grouping. There are 4 things here, so we can factor by grouping. We had 2 different ways of factoring by grouping. One of the ways is to look at this first set and this second set. In this first set, we can factor out an A, leaving us with B plus C. And here, because it has a leading negative, we have to factor out the negative and the D, and we'll be left with B. A lot of people put minus C, but the thing is we factor out the negative, so this is a plus C. Sign to check, these parentheses should match because we're going to factor out the GCF, which is B plus C, and we will be left with A minus D. So that's how the numerator factors. The denominator, you'll remember that there's another way of factoring, which is using the box. We'll have AB minus BD minus AC plus CD. It goes 1, 2, 3, 4. You can also go 1, 2, 3, 4 when you're putting them in. If it has a leading negative, you have to factor out the negative. And if you look here, we can also factor out a C. If you look here, both of these have the letter B. If you look here, both have the letter A. These have a leading positive, so these are positive. This has a leading negative, so we take out a negative, and we have D. When we read this, we're going to read it out this way. So this is one set, and this is the other set. So we'll have B minus C and A minus D. I don't care which way you use to factor these. You might have a teacher who does. So numerator and denominator. I said we have to factor, cancel, and write a better answer. So we're going to have B plus C, A minus D, over B minus C, A minus D. Factor, you'll see that these match exactly the entire parentheses. You can't just take part of the B and then part of the C and ignore those. It has to be the entire set. You're going to cancel that and write the better answer. When you write this, since these parentheses are all by themselves, they actually don't need the parentheses anymore, and that is your answer. If you have the parentheses, that's okay too. Chapter 6, Section 1, Question 3. We're going to again factor, cancel, and write a better answer, but look at how much longer these are. You're going to have to factor 4 things, and this is why we covered Chapter 5 before getting to Chapter 6. So if you look at the first one, this is a difference of squares. A perfect square minus a perfect square. That will factor very nicely as 3x minus 2 and 3x plus 2. If you wrote 3x plus 2 and 3x minus 2, that's fine. Now, this one, we might want to do the Snowflake Method. Remember the Snowflake Method? You're going to take 3 times negative 6 and get negative 18 on the top, negative 7 on the bottom, multiply to give you the top, add to give you the bottom. Those two numbers are going to be 9 and 2. To get a negative 7, I want a negative 9 and a positive 2. Here, I want 3, the A number goes on the top, and I'm going to see if I can reduce. I can reduce 3 over 9 to 1 over 3, and this negative has to stay on the bottom so that I can write out this answer. 3 over 2 does not reduce. And that's going to tell me how to do that one. And this is going to be an x minus 3. So 1x minus 3. The second one will be 3 and 2, so 3x and positive 2. Another snowflake problem. This time, a times c will give me a negative 6 in the numerator and a negative 5 in the denominator. I want to multiply to the top, add to the bottom. That's going to be a 6 and a 1. Wait, no. Let's see. If I have a negative 6 and a 1, that will work. All right. And then the 2 will go on the top. I can reduce this way, and I'll get 1 and negative 3. And this one will not reduce. I'll get a 2 and a 1. What that means is we'll have x minus 3 and 2x plus 1. This last one is a soap problem. We have a cube plus a cube. That's for the sum or difference of cubes. So we're going to break that up as 2x, same sign, so plus 1. That's same. We're going to use opposite and always positive. This 2x, we're going to take 2x times 2x to get 4x squared, opposite sign. 2x times 1 will give me 2x, always positive. 1 times 1 will give me 1. Notice how short my vinculum is. I'm going to need to extend that out. This is a factor. We're then going to have to cancel and write a better answer. I see a 3x minus 2 on the numerator, and I'm going to check the denominator. I don't see another one like that. I see a 3x plus 2 on the numerator, and I find 1 in the denominator. If I were to find 2 in the denominator, I can only cancel out 1 for the top and 1 for the bottom. X minus 3. I see an x minus 3 there. 1 for the top, 1 for the bottom. 2x plus 1, 1 for the top, 1 for the bottom. There are things that aren't canceled out, so that's part of my answer. Once again, because those are all that are left in the numerator and the denominator, I don't need the parentheses anymore. In the event that everything canceled out, that would give you a 1. But since we have things left, we have that for our answer. Chapter 6, Section 1, Question 4. Again, we're going to factor cancel and write a better answer, but before that, we have a division symbol. We're going to have to multiply by the reciprocal, or many of you learned to copy dot flip. So this is going to be 6x squared plus 11x minus 10 over 6 minus 9x. The dot means multiply, and then we have 3x squared minus 27 over 2x squared minus x minus 15. I'm going to shorten that vinculum. The first one, this is a snowflake problem. So a times c, 6 times negative 10 gives me negative 60 with an 11 in the denominator. Multiply to give you the top, add to give you the bottom. Gosh, if we're not sure how to get that, we can look at 60. That is 1 and 60. 1 would be negative, and I'd like the smaller one to be negative. That would give me 59. 2 and 30. We're getting closer. 3 and 20. We're getting closer. 4 and 15. There it is. I could keep going, but since I found the one that gives me 11, I have negative 4 and 15. And I have a 6 in the numerator. I want to reduce. I can divide by 2. And I can divide by 3. And I want to always read these going down. So that will give me 3x minus 2 and 2x plus 5. This one here, I can actually change the order of that around from 6 minus 9x to negative 9x plus 6. You remember that we wrote them in descending order by degree in chapter 5. And since it now has a leading negative, we want to factor out the negative 3. And we're left with 3x minus 2. we have 3x squared minus 27. It's not looking good, but I see that once again I have a common factor. I can factor out a 3 and I'm left with x squared minus 9, but now x squared minus 9 is a difference of square. A perfect square minus a perfect square. So that can factor as x plus 3 and x minus 3. If you wrote x minus 3 and x plus 3, that's perfectly fine. And then here we have another one that would be good for the Snowflake method. 2 times negative 15 would give me negative 30 with a negative 1 on the bottom. Multiply to give you the top, add to give you the bottom. Negative 6 and a 5. A is on the top, which is 2. We reduce and we get 1, negative 3, and 2 and 5. Always reading going down, keeping that negative in the denominator. And so here we have x minus 3 and 2x plus 5. This is the factoring. This will give you half credit. I want to make sure that I can read this, because if I cannot read your answers, I can't give you the partial credit. So we're going to check, can we cancel? I see a 3x minus 2 in the numerator. I see a 3x minus 2 in the denominator. I see a 2x plus 5 in the numerator. And the other one is way over here. Some people are not sure whether or not they can cancel that out. Yes, you can, because it's being multiplied. If it was being added or subtracted, you couldn't do that. If it was being divided, you couldn't do that. Numerator, denominator, 3 on top, 3 on the bottom. This 3 will cancel out, and this will leave you with a negative 1. X plus 3 on the top, x minus 3 on the top and bottom. So if we look, we have an x plus 3 in the numerator, and we have a negative 1 in the denominator. I will accept this as an answer. However, some students pointed out that you could actually take the negative 1 and move it up to the numerator, and you could get negative 1 times x plus 3, and that would also be the same thing, because a negative 1 in the denominator, a negative 1 in the numerator, same thing. I would also accept this. And some people said that since it says simplify, that they would actually either divide or multiply this and get negative x minus 3. I will tell you that at this level of math, I will accept all 3 of these answers, but if you're looking for the best one, this is probably the best answer. Chapter 6, Section 1, Question 5, Type 1 of 2. So this one, we're finding what goes in this missing part here, this box. You'll notice that we have an equal sign. This is much harder than a normal problem. So what we're going to do is we are going to take the left-hand side and we're going to factor cancel and write a better answer. But then, just like in Chapter 2, we're going to make a common denominator. And it's going to come out very nicely. This works nicely with our Snowflake method. 4 times 9 is 36 in the top, 12 in the bottom. And hey, that comes out nicely as 6 and 6. That's actually a perfect square trinomial. The 4 go in the top, and 2 over 3 and 2 over 3. And the reason is, perfect square trinomial, it's going to work out as 2x plus 3 and another 2x plus 3. In Chapter 7, we're going to write this as 2x plus 3 squared, but for right now, since we're trying to cancel out sets, it's better to write it this way. Here, I have another one that works very well with the Snowflake method. 4 times negative 15 is negative 60 with a negative 4. We just did this one. That was the pair 15 and, nope, that is not the pair. We need a different pair. We need 6 and 10. To get a negative 4, I need a negative 10. 4 will go on the top, and 2, 3, and 2, negative 5. Reading going down. We have 2x plus 3. I know that it's going to factor out and cancel, but I don't want to do that yet. I want to make sure that while my brain is still in factoring mode, that I can still factor. I don't know what this one is, but I see that that is a perfect square, or a difference of squares. So that's going to factor as 2x minus 3 and 2x plus 3. If you wrote 2x plus 3 and 2x minus 3, that's fine. Now that we've factored, we're going to cancel numerator and denominator, numerator and denominator. And we're going to write the rest of it equals 3x plus 1 over 2x minus 3. We need to make our common denominator. You'll notice that here we have a 2x minus 5 and a 2x minus 3 on the left. We have a 2x minus 3 on the right. What else are we going to need to make a lowest common denominator? What's missing is we're missing a 2x minus 5. And if we put it on the bottom, we have to be fair and put it on the top. Just like in chapter 2, you'll notice that everything on the numerator has been canceled out except for what goes in this box. So now that everything on the bottom matches everything on the bottom, everything on the top will match everything here that would go in that box. Some students want to stop here, but if you look at the instructions, it says determine the polynomial that creates a true statement. This is not yet a polynomial. In chapter 5, we learned to multiply two little polynomials together, and if we multiply that together, we'll get 6x squared minus 15x plus 2x minus 5 using FOIL, and then the middle two terms can combine, and we get 6x squared minus 13x minus 5. That is what goes in that little box. If it makes you happy to put it in the little box, you are welcome to write it in the little box. Just make sure that I can read it. 6x squared minus 13x minus 5. But whether you box it up here or you box it over there, it should be fine. Chapter 6, Section 1, Question 5, Type 2 of 2. Here, you might remember this from back in Chapter 5. We have the area of a rectangle and one side, and we're solving for x. Remember that the area formula for a rectangle is area equals length times width. That is a script L. So if we were to plug it in, we would get 15a squared minus 8ab minus 16b squared is equal to the x that we're looking for and the 5a plus 4b. Now, one of our college professors really wants this x to be on the left-hand side. So I'm going to factor this, but when I rewrite it, I want my x to be on the left-hand side. Now, this is a very clever problem. This one has a hint as to how it factors. We are looking for this one, but we already know that one of the pairs should be 5a plus 4b. So we can look at this. To get 15a squared, we would take 5a times what? 5a times 3a would give me 15a squared. To get the last thing, we have a positive 4b, and here we'll need a negative 4b. And that will give me negative 16b squared. We do have to check. This is negative 20ab, and this is 12ab, for a total of negative 8ab. That is wonderful. If you do this checking in your head and don't show that work, that's fine at this level. So here we have the two sides, and we're solving for x. To get rid of a multiply by 5a plus 4b, we're going to divide by 5a plus 4b. Notice the parentheses, very important in this case, because we want to make sure that this 5a plus 4b, that you don't take this 4b and cancel it with that 4b and that 5a and cancel it with that 5a. We want to make sure that the entire set 5a plus 4b cancels with this entire set 5a plus 4b, and same thing here. So this one, we're going to factor, cancel, and write a better answer. It's a little bit different. In chapter 5, we did this by long division. Long division would still work, but the reason that it says that we're going to show work by factoring and canceling is we're trying to support the chapter 6 method of solving this. So this is 3a minus 4b. Now, because this is a word problem, these parentheses are appropriate, and then we would label it. If you look, it's labeled in M for